the previous lecture we have discussed about the introduction to group, and we have seen the definition of groupoid, semi-group, what is algebraic structure, and so on, and what are the properties. Okay. In this section we will discuss about the definition of group, which is the heart of this our course. Okay. So the group is nothing but a non-empty set of elements G is said to be form a group if in G there is defined and binary operation. What is binary operation? That we have discussed in the previous section or previous lecture. And the algebraic structure consisting of G star. G may be any binary operation, it may be addition, multiplication, and so on, which satisfies the following properties. Here are we have four properties. First is first is closed property, associative property, existence of identity, and existence of inverse. These four things are very important to form a group. If these four properties are satisfied, then we say it is simply a group. Okay, so let us discuss about the first closed property. Okay, so in the previous lecture also we have discussed what is in by closed property. Okay. Closed property is nothing but if we consider any set, for example, we have considered about the set of natural numbers. Okay, and in that we have seen the natural numbers are 1, 2, 3, and so on. What is a closed property? If we take a binary operation, that is addition. Okay, addition is binary operation, so n star or n plus, that we have discussed. How the closed property is satisfied? If you take any two elements, that is let us take 2 and 4. If we add this 2 and 4, we get 6. And obviously 6 also a natural number, so it consists in the this set n. Okay, so it forms a closed property. Is a closed property. Okay. Next, that is we have discussed, that is a associative property. Okay. Associative property. For associative property, we will take an example. For example, if we are consisting of the okay, we will consist about the set of natural numbers n plus. Okay, so and this natural numbers we know, there's 1, 2, 3, and so on. What is associative property? If you take any three natural numbers, let us take 2, 4, and 6. Let's start 5. Okay, so what this property says that for A, B, C, that's any three elements belonging from that set, we have consisting natural numbers, and if we take a binary operation, so if we take this in that order, that is 2 plus 4 plus 5, it is equal to, that is a 2 plus 4 plus 5. Okay, it's not much more hard. We have to solve the bracket. 4 plus 5, 9, plus 2 is equal to 2 plus is 6 plus this 5. This 2 plus is 11, and this is also an 11. So LHS is equal to RHS, and this property is known as associative property, that we know. Okay, next property is existence of identity. Okay, so for this set of natural numbers, existence of identity. What will be identity? Yes. So please concentrate here. There exists E belongs to G such that A star E is equal to E star A is equal to A for all A belongs to G. For this set, we should have an element such that here we have an operation, the binary operation is addition. So if we take any number, let's take any number, then let us 2. Okay, natural number. We have to add a number E such that 2 plus E or E plus 2 should be equal to 2. So there exists any number such that if we add this 2 to that, we will get 2, and in the natural numbers. Okay, obviously this is not satisfied. Okay, no? Why? Because for this we required 0, means 2 plus 0 is equal to 0 plus 2 is equal to 2. And this 0 does not belongs to natural numbers. Okay, so for this we have to think about the next set, and that is whole numbers. Okay, we will discuss this number theory part also, and simultaneously definition of the group. Okay, and when we see about the whole numbers, in that we exist this, right? Because 0 belongs to set of whole numbers. Okay, next thing we have to think about the existence of inverse. Okay, what the inverse? Inverse is that for every A belongs to G, there exists A inverse. Okay, belongs to G such that A into A inverse or A inverse into A should be equal to an identity element. Okay, for example, 0 is an for this case when we discuss, obviously the associative property and close property satisfies in the whole numbers, a set of whole numbers with respect to addition. Okay, and 0 belongs to this whole number, so we have get an identity. We are not taking an will when we are discussing examples, that time we will see how these definitions work out. We have to understand these properties. Okay, so let us think about that existence of inverse. Okay, so we have to take an element. If you take an element 2, the previous 2, we have to, obviously we have operation addition 2 plus some element A inverse such that this should be equal to, that's A inverse plus 2 should be equal to the element identity. Here the identity element is 0. Okay, yes, this is possible that we have to add such element so that our answer is 0. Obviously in the whole numbers it is impossible. It is possible in the set of integers or I. Okay, so here we get an element 2 plus minus 2 is equal to minus 2 plus 2 such that our answer is 0. Okay, this exists in the set of integers. Okay, so in this way there is evolution of number theory, how we are coming from natural numbers to whole numbers to integers. Okay, and when we discuss about more examples regarding the group, we are also discuss about how the we can understand how the rationals, irrationals are existed. Okay, so these are the 4 properties that should be satisfied by any set to form a group. So again we'll revise. A non-empty set of element G is said to form a group if in G there exists a binary operation star, that is, which forms an algebraic structure G star. We will take the for group G, but when we are thinking about particular examples, that time we have to think what is that set denotes. Okay, which satisfies the following properties. And the properties are closed property, associativity, existence of identity, and existence of inverse. These are the properties of, obviously we know that is properties of numbers system. Okay, one more property that we have escaped, that is commutativity. Okay, so when a group G is said to be commutative, or that is abelian, or if for every A belongs to J, A star B is equal to B star A. If this property is said, with these 4 properties, a set also satisfies the commutative property, that is A star B is equal to B star A. That time this type of group is called as an abelian group. One more thing, if we say that this is a group, so this group is also called as associative group. Simply, when we say that simply a group, that time we will say, we have to assume that this is an only associative group, because in the associative property is satisfied. But when we say that abelian group, that time with these 4 properties, one more property is required, that is commutativity. This is about the definition of group. Okay, so the examples of this that we will discuss in the next video or next section. Okay, thank you.